Hello everybody and welcome to chapter 7 of advanced functions. We only have 2 chapters left to do, including this one, which is an amazing feat. So today and for the next couple of lessons we'll be looking at tools and strategies for solving exponential and logarithmic equations. So in the last chapter we learned what a logarithmic function is and how to graph them, as well as several little strategies we use to find values for a logarithmic function. So all of chapter 7 is essentially a continuation of that, but it also is a lot more algebraically based. So be prepared to write a lot of equations and solve for a lot of variables. So let's get started. Chapter 7.1 is an introduction to equivalent forms of exponential functions, or equations I should say. So first of all, we're gonna go over how to change the base of several powers. So for example, how we can transform 8 into 2 to the power of 3. Once we do things like that, we will use this property to solve an equation. So let's talk about the change of the base of powers. So exponential functions and expressions can be expressed in different ways by changing the base. So as an example, we can have something of the following 3. We know that we can change 8 into 2 to the power of 3 because 2 to the power of 3 is 8. So that is just an easy way we change something of the base of 8 to the base of 3. This is a huge step up from that, but it still follows the same core mechanics. So let's take a look at what happens here. I'm saying that this whole expression over here, let's take a pointer, is equals to 3 to the power of 5.5. Now, this explanation here will tell you how I derived this. So first of all, we are presented with a very complex expression, but we could start looking at different parts of it so it makes our life easier. So first of all, let's look at the square root of 9. We know what the square root of 9 is. It is 3. So the square root of 9 is the same as 3 to the power of 1. We also know that the root of 27, or 27 itself, is 3 to the power of 3. So we can write that as the fourth root of 3 to the power of 3 all to the power of 6. Then using properties we learned about exponents, we know that we can rewrite this using power over the radical expression. So we actually have 3 to the power of the power, so 3 divided by 4. From here we know that if we have something to the power of something to the power of another thing, all we have to do is multiply the 2 exponents together. So 3 over 4 to the times 6, will be 18 over 4. So what we have now is, instead of this complex expression here, we have 3 to the power of 1 times 3 to the power of 18 over 4. We know for multiplying 2 exponents together in this kind of form, so 2 of the same basis, different exponents, we actually just add the 2 different exponents together. So I skipped the step on showing you how to add these, but all you would do is, you know that 1 is the same as 4 over 4, so we do 4 plus 18, all divided by 4. 4 plus 18 is 22, and that is how we get our answer. From here, I personally don't like working with fractions, so I transformed it and changed the fraction into a decimal, which is 5.5. So we went from here all the way to 3.55. As you can see, it takes some time, but it will make our life a whole lot easier, as it is much more simple to work with something of a base of 3 rather than the base of a square root of 9 times the fourth root of 27 all to the power of 6. Next, let's talk about this bad boy here. This bad boy, you may be thinking like, what did we just do? We took a whole number and then change it to the base of 3. First of all, 13 is a prime number. It doesn't even factor. So how did we do this? Well, to do this, we can set up an exponential equation. We know we're looking for something that when we raise 3 to the power of it, we get 13. With this equation, we could take the log of both sides. Again, this is the same as like dividing everything by 2, or raising everything to the power of 7. It's the same kind of procedure. It doesn't change the outcome. So when we take log of both sides, we get log of 3 to the power of k is equals to the log of 13. Then using the power law that we learned a couple of classes back, we know we can rewrite this guy as k times log of 3. And that is still equals to log of 13. Now, when we isolate for k, so we divide both sides by log of 3, we get that k is equals to log of 13 over log of 3. Since this was our k value, we can now substitute our k value into our equation, and we find out that 3 to the power of log 13 over log of 3 is equals to 13. Doing this procedure has now allowed us to essentially change any positive number as the power of any other positive number. So if this was 15, for example, that wouldn't change a single thing. Our answer would simply be 3 to the power of log of 15 over log of 3. You can do this procedure for any number, which is why it is super important for you to understand, because we will be using this property when it comes to solving exponential equations. So now that we've discussed that, let's actually solve some equations by changing the base. Again, as I said, changing the base just lets you work with more pretty numbers and lets us actually find a very useful technique for solving these equations. So at first, let's look at this equation here. 25 to the power of x minus 1 is equals to 5 to the power of 3x. Immediately, we can identify the fact that 25 is simply 5 to the power of 2. So now I'm just going to substitute that for 25, and we get 5 to the power of 2 to the power of x minus 1 is equals to 5 to the power of 3x. Opening these brackets here, we actually find out that we can write it as 5 to the power of 2x minus 2 is equals to 5 to the power of 3x. What's important for us to understand here is that since our bases are the same, the only thing we care about is now our exponents. So all we have to do is equate them. So now our equation is 2x minus 2 is equals to 3x. Isolating for x, we could bring 2x to the other side, so we get 3x minus 2x, which is equals to x itself. And then we just have a negative 2 left over. And so we find out that our answer is negative 2, x is equals to negative 2. If you want to see the solution, we can easily graph it on Desmos. So let's do that. So here you go. I wrote the equation in Desmos, and it immediately let us know that our answer is negative 2. We can do this in a different way. For example, we can first graph our first part of the function or the equation, then we could graph our second part. Then wherever they intersect will be our answer. So over here, the graph shows us that our intersection point is at negative 2 at the value of 0.001. So that would be our answer. As you can see, we can use this to solve any type of exponential equation. So for example, let's solve another equation. So this is what we have. 9 to the power of k minus 1 is equals to the square root of 27 all to the power of 2k. So from here, again, let's identify the two parts we have. The first part is 9, which we know we can write as 3 to the power of 2. And then 27, which we can write as 3 to the power of 3. So now our equation can be written as 3 to the power of 2 all to the power of k minus 1, or the square root of 3 to the power of 3 all to the power of 2k. Opening the brackets, we actually get like 3 to the power of 2k minus 2 is equals to 3 to the power of 3 over 2. Again, this is the power over the radical form that you learned last year. And then still to the power of 2k. Opening the brackets even further on this side, we get that 2k times 3 over 2 cancels out the 2's, so we're just left with 3k as our exponent. Now that our bases are the same and we have no brackets left, we can just once again equate the exponents, and so we get 2k minus 2 is equals to 3k, bringing 2k onto the other side. We once again found out that our answer is -2. So actually we got really lucky here, we got 2 of the same answers. So let's check whether or not Desmos gives us the same answer. Again, I graphed the function here, and as you can see, our answer is still -2. So we did everything correctly. Again, I really want to emphasize the fact that any exponential equation can be solved using tech. So if you get a really difficult question in the textbook and you have no idea how to solve it, you can always just plug it into Desmos and see if it is even solvable, okay? Because sometimes people might write things the wrong way, or something just goes wrong within your own procedure, and so you get confused and think things are impossible. Using tech will provide you a clear-cut way to see if something is possible or not. With that being said, this is the homework for today. It is not that long. Some of these questions will not take you more than a couple of minutes. So for example, let's actually look at some of the things I've assigned. So this is chapter 7.1. As you can see, I've assigned chapter 4, which is just changing the base. Should be pretty simple. Then I've assigned 2 of these, which is following the exact same procedures as the examples I've done. This guy here is a word problem, but it's still asking you to solve this equation, so nothing too difficult. Same thing for this guy here that I've assigned. And this guy over here is actually the same type of question as we did for when we were transforming this into this. It's the same type of thing with just general variables rather than concrete numbers. So as you can see, nothing about this chapter is extremely difficult. It just requires you to turn on a certain part of your brain and start realizing and visualizing how different numbers can transform into other ones. And if you can get this concept down, chapter 7 will be a breeze. And after that, we just have chapter 8, which is completely unrelated, well, related, but it's related to everything we've done in the course. So it won't be way too over the top. So yeah, with that being said, I'd like to thank you for listening to today's class. It is probably one of our shortest ones thus far, just because of the lack of really difficult concepts that were covered. Everything today was pretty straightforward, but if you feel as though you're not confident in the content we've covered, or you still have some questions, or even like another question you got from school that you want me to cover, please feel free to email me or leave a comment down below. Otherwise, if you've enjoyed this video, also don't be afraid to leave a like, it always helps out. But most importantly, I really hope that I'll see you next class. Bye bye!